mechanics labs, and today we have to perform experiment number 1, and that is about friction between two surfaces. For that, the objective of experiment is basically to determine the coefficient of friction between two surfaces and show that the limiting static frictional force is proportional to the normal reaction. Okay. This
basically you have to determine the coefficient of friction between two surfaces, and down there is a procedure, and on the next page you have basically two tables. The first one is basically to find the average coefficient of friction between two surfaces. Okay, for that actually we have two surfaces. The one is rubber here, and the other one is brass here. So using this equipment, we have here precision friction apparatus in our lab. We have to find the force, the coefficient of friction between brass and this rubber. Okay, so if we see the details of the equipment, what we have actually, there is a power switch on the right side, and it's on mode right now, and on the left side there is a switch forward and reverse. This switch is actually basically to move this tray forward and reversed. So now it's on reversed mode and it's moving away. So if I turn it on in forward mode, so it will move in forward direction. Okay, there is a force gauge here as well. Okay, it's marked, its one division is basically 0.05 Newton, and it has total capacity of 10 Newton. In this dial gauge, what we have, basically we have reading marked here after 2 Newton. Okay, so after there are basically 40 divisions from 0 to 2 Newton. For every 10th division is actually that is dark, slightly dark as compared to the other one. So if right now, for example, if I want to read this reading, what would I read? Right now it's actually this one is 40 and it's approximately 39 division here. So what would be the force here? That would be 39 multiplied by 0.05 Newton. So I would get the force reading from this one. Before starting the experiment, you have to have to keep it in mind that these two hooks should be aligned. Okay, this one is for the force gauge and this one is for our material. तो ये दोनों क्या होनी चाहिए, एक्चुअली अलाइन होनी चाहिए, क्योंकि अगर ये अलाइन नहीं होंगी तो फोर्स बेसिकली एक एंगल पे हो जाएगी, एंड इन दैट केस द फोर्स ऑफ फ्रिक्शन वुड नॉट बी इक्वल टू दिस वन. So this value, this force reading, this force gauge actually give us the value of the frictional force. There is a reset button here as well. It's basically उसको 0 पे सेट करने के लिए हर बार. तो right now it's at 0. So how can I start my experiment? For that purpose, I will just put it here at the middle, and from here I would move this tray in backward direction. So it's moving away. Now if you move, okay, so we have noticed this value. Okay, one complete division, and after that there are 40, 50 and 55 division approximately. So it's 1 complete division, 10 Newton plus this one. So this force gauge actually would give me the value of the friction as well. So I would use this value in this table. Right here I have the limiting static friction, the maximum friction I have noticed from the dial gauge. So I would write that reading here. So that would be counted here for the normal reaction. In that case, for a surface on a horizontal surface, for a block on a horizontal surface, that normal reaction actually would be equal to the weight of the body. So for that purpose, I would just weight it. So that's physical balance. So the weight of the brass I have here is 881 grams. So converting it into Newton, so I would write the normal reaction here, and the coefficient of friction would be the force reading, dial gauge reading, divided by the normal reaction. So we have to perform actually this experiment for this material, for the rubber and brass, for 4 to 5 to basically find out the coefficient of friction between the two surfaces. So I would again perform the second reading on the same experiment, but first keep it in mind, okay, this one is just disturbed, okay. So if you just lose the string, okay, there is no brass here, okay, there is no brass. Actually this dial gauge is set accordingly that, okay, it stops at the maximum reading even if you disattach the block. For example, I would do the experiment again and I'll show you. Okay, this one is again moving in forward direction. For the second reading, I would just reset it and I would again attach the cord here. Okay, just keep it at the middle. Okay, so this one is here. Now I would again, this one is at 0. I would again reset it to 0. Okay, for the second reading, I would just move it. और जैसे ही ये स्लाइड करना शुरू होगा तो जो मैक्सिमम फोर्स रिक्वायर्ड है स्लाइडिंग से पहले वो यहाँ पे एक्चुअली नोट हो जाएगी. इट्स अगेन वन कंप्लीट डिवीजन एंड दिस वन इज अप्रॉक्सीमेटली अगेन द सेम रीडिंग बट इट्स between now around about 10, 20, 30, 40, 50. It's approximately again between one complete revolution plus 55 and 56 in between. So this one is your second value, and for the third value I would again do that. I would again move it in the forward direction, okay, but you can notice that the string is not like there is no tension in the string now, but the dial gauge reading is there. It actually stops at the maximum value of the of this friction. So actually this notes the limiting friction value. So we can call that that's a limiting friction value. For the third reading, I would again reset it. Again, I would check it. It should be at 0, and I would again move it in the reverse direction. Okay. जैसे ही ये स्लाइड होना शुरू हो जाएगी उसके अकॉर्डिंग जो मैक्सिमम वैल्यू जो उसको स्लाइड करने से पहले होगी, स्लाइड तो नहीं हुआ था. Okay, it's moving in reverse direction. One complete revolution and this one. So it's again at one complete revolution plus 56. So the force of friction is approximately same in so we can say that there is a precision in experiment reading. So all these values of the friction we can note down here, okay, in this table, and the normal reaction that would be equal to the weight here, and we can notice this coefficient of friction here. So in this way we can perform this experiment. For the fourth reading, I have just reset it again, and I would again move it in reverse direction. Okay, this one is your fourth reading. It's again between one complete revolution, and this one is between 55 and 56. So 50, I can approximately mark it at 55. So 55 multiplied by 0.05 plus one complete revolution, so that would be 10 Newton, 10, 12, 13 point something. So this is your fourth value, and you would the first part of the experiment has been done. For the second part, what we have to do, we have to basically prove that the force of friction, like this value, the force of friction to pull it this way is directly proportional to the normal reaction.